Today we're going to be looking at solving a system of equations by graphing. A system of equations. What does that mean? Why are we saying system? Well, it's two or more equations with the same variables, and we'll only be doing two in Algebra 1, but when you get into Algebra 2 or after, you'll be doing three equations with three different variables. To solve a system of equations with two variables, find the ordered pair that satisfies both of the equations. So we're looking for a point that they both share, or where they intersect. There are three possibilities, three possible solutions to a linear system. First, we have the possibility of one solution, meaning that they intersect in one spot. And we can see that intersection by looking at where they are crossing each other. And that would actually be the solution, but we'll get to that in the next examples. It's also considered to be consistent. That means it has a solution, so it's consistent, and that they're independent. They don't depend on each other, the lines, so that's considered independent. For the second example, it looks like one line, but it's actually two lines that are exactly the same. Same line. They're exactly the same. Still two lines there. In this case, we have infinite solutions because they intersect everywhere. Infinite solutions. This is also considered to be consistent because consistent just means that it has a solution. But these ones are not independent. They depend on each other. And they're dependent because they're actually the same. The third example is two lines that never intersect, or what we know as parallel lines. And parallel lines have no solution. And they're considered inconsistent because they have no solution. So let's look at the following example. In each problem, we're going to look at the two lines and decide if there's one solution, no solutions, or infinite solutions. If there are infinite solutions, or if there's one solution, we're going to name it. So first we're looking at x plus y equals 3. X plus y equals 3 is this line right here. And we are looking at 2x minus y equals negative 3. So this line right here. Now I can see that they do intersect. So they have one solution. But then I have to look and see what is that solution. And looking at that, hard to tell on this graph where our x-axis is, but it's down here. Our x-axis is down here. And then our y-axis is right here. So if I'm looking at that point, it's at 0, 3. So that is what I believe my solution to be, 0, 3. So when you have one solution, you do have to tell me what it is. Checking. We can only check when we have one solution, and that's when we just plug our solution into each equation and see if it works. So I'm looking at that first equation, 0 plus 3, does that equal 3? That's a question mark. Well, does it? Yeah. 0 plus 3 is 3, so 3 does equal 3. We have to check it in both, though, because it has to work in both. That was the first thing we said. So 2 times 0, so now I'm looking at this equation, 2 times 0 minus 3 equals a negative 3. So 2 times 0 is gone, and negative 3 does equal negative 3. So it works. Okay. Now we're looking at two different equations, so I'm going to erase that. And we are looking at 2x minus y equals a negative 3. That's the one that actually we just did look at. And this next one, 4x minus 2y equals a negative 6. Well, I don't see that on this graph. But when I take a look at this equation, it's a little strange. I notice that 4, 2, and negative 3, that equation's really not in its simplest form. I could divide all of those numbers by 2 to clean it up. 2x minus y equals a negative 3. Well, it's the exact same line. So if it's the exact same line, we have infinite solutions. Because they share every point. And if you have to, you can go back up to the top and look, see that that was the middle graph. Infinite solutions we're not checking. The only ones we're checking are one solution. So one solution, 0, 3, we checked it. Infinite solutions we don't have to check. Next one. X plus 3 equals a negative 3. So that's, or x plus y equals a negative 3. So that's that line. And then x plus y equals 3. That's that line. I can see those two lines are parallel. If I look up above what's parallel lines, they never intersect. That means I have no solution. Don't have to check that one. The only one I have to check, or that I can check, is when it's one solution, because I can plug that answer in. And then our last one is 2x minus y equals a negative 3. And that is this one. We have, oops, wrong color. We used that one already. And 3x minus y equals 1. That's this one right here. So I can clearly see that those intersect. Looks like right there. So it does have one solution. Now, sometimes it's hard to tell where that solution is. That's the problem I'm having right there. It's a little hard to tell. Oops, scooched up too soon. Let me check it. It looks like it is at 1, 2, 3, 4, 4, and then up 11, right? So that's 4 on the x, 11 on the y. So it looks like 4, 11. But it is a little hard to tell, and it's easy to make a mistake, and that's why we check it when it's one solution. Because if we plug it in and it doesn't work, we didn't quite read the graph right. So I'm going to plug it into that first one. 2 times 4 minus 11 equals a negative 3. And I'm checking to see if that's true. 8 minus 11 equals a negative 3. 8 minus 11 is a negative 3. That works. I'm going to check it in the second one. 3 times 4, because that's my x, minus 11 equals 1. So that's 12 minus 11 equals 1, and 1 equals 1. That's true, so it does work, and I know that my answer is correct. So anytime you have one solution, you should be plugging it in and checking it. And you do have to plug it into both equations. All right, on the back, we have another example. In this example, we're actually going to be graphing it. We're not going to be provided the graph. We have to graph it ourselves. And that's the whole reason why you do have to pass part 1 to get to part 2, because we're going to expect you to be able to use those skills. So I'm going to graph this first one in red. Easy one, because it's already in slope-intercept form. I start at 1. I go up 3. 1, 2, 3, over 1. Up 3. 1, 2, 3, over 1. I'm also going to go down, 1, 2, 3, and then back 1. 1, 2, 3, back 1. Get a line up, no line. So there's that line. Second one I'll do in blue, but that one's not in slope-intercept form. So I have to use my part 1 skills. Negative y equals negative 3x plus 4. Move that x over, divide by negative 1, and remember to divide everybody by negative 1. Y equals 3x minus 4. So this one, I'm going to start at negative 4, move up 3, 1, 2, 3, over 1. 3, 1, 2, 3, over 1. Up 3, 1, 2, 1, 2, 3, over 1. Up 3, 1, 2, 4. Doesn't intersect. So on this one, they are parallel lines, which means I have no solution. Because it's no solution, I can't check it. There's nothing to check. Also, maybe if I remember some part 1 stuff, remember we said that parallel lines have the same slope? So if I remembered that, I could just look at those equations once I had them in slope-intercept form, and I would automatically know those would be parallel, which means they would have no solution. All right, you have 2 problems to do on your own. Go ahead and get started.